Okay, I'm back, and now we want to talk about seafloor spreading. So we already talked about continental drift, and that is going to be part of plate tectonics. Now we want to talk about seafloor spreading, which is another part of plate tectonics. So we want to show, or the evidence that shows that the seafloor is, at least in certain parts of the earth, is spreading apart. So that we're going to find out eventually that you've got two plates that are going to be moving away from each other. So this one's moving this way, and then this one's moving this way. So this is a cross section of what's going on. So we got one plate that is moving in this direction, and then another plate that's moving in this direction, and then this is going to cause seafloor spreading. So how do we know that this is occurring? So the first line of evidence is the thickness of the ocean sediment. So when they find one of these places, so this is going to be called a divergent zone, where the two plates are diverging, they're going away from each other. Whenever they took their submarines and went to the bottom of the ocean and they looked at a place where these plates were being pulled apart, they noticed that the sediment was the thinnest right here, and then the further away you got, the thicker the sediment became. So the sediment was the thickest, the furthest away from the plates, and then where these plates were coming apart, that's where the sediment was the thinnest. Well, that would make a certain amount of sense, because if this is where you're creating new ocean floor, it would be very young here, and so it wouldn't have had time to develop a whole bunch of sediment on top of it. Okay? So the second line of evidence is the composition of the oceanic crust. And what they noticed was that the oceanic crust, on the other hand, was getting thicker the further the way that you went from it. So again, the oceanic crust was turned out to be very thin right here, and then the further away that you got, the thicker that this crust would get. Now this time it's getting thicker because of temperature. So as it cools off, the stuff that used to be molten starts to cool off, starts to freeze, starts to turn into solid rock. So it's very thin here, and then the further away that you get, the cooler it gets and the thicker that this material starts to get. Okay, let's go to the next one. Another evidence for seafloor spreading is where are the hot parts of the earth. So the heat distribution. And so the hottest parts of the earth are going to be in red, and then the coolest parts of the earth are going to be in blue. And so look at where all that red is located at. Do you notice that the red is going in between North America and Europe, where that volcanic mountain range was located at? And then do you see that it wraps around South America, and then you've got that other band of where heat is coming up, and that's another volcanic mountain range. So the seams of the baseball are also going to be areas where a lot of heat is coming up from the interior of the earth. Okay, now let's look at earthquake distribution. So do you see how it kind of makes a ring? So that's called the ring of fire, that thing that goes up the western coast of South America, and then it goes up the western coast of North America, then it goes across the Aleutian Islands, and then it comes down the eastern coast of Asia, and then goes down there by Australia. So this thing that kind of wraps around the Pacific it's called the Ring of Fire, and there is a lot of earthquake activity that goes on there. So we think that this is places where the plates are, again, colliding, and so this is going to cause a lot of earthquakes to occur. So whatever theory that we come up with is going to have to explain this heat distribution thing, and then the fact that there's lots of earthquakes located around the rim of the Pacific. You'll also notice again that there's earthquakes that are in between North America and Europe, and then South America and Africa, and they're right in that volcanic mountain range. But you notice not as many earthquakes. So not as many earthquakes are associated with these volcanic mountains as there are associated with the edges of these plates. So this theory that we're going to come up with is going to explain that. All right, let's take a break, and when we come back, we're going to talk more about magnetism.